T-class just says that if three gas molecules have velocities 0.5, 1, and 2 kilometer per second. Now you have to find out the ratio of the RMS and the average speed. So for calculation of the RMS, what did I tell you? RMS, you have the word as root mean square. But when you are solving it, you first take the square. So this will be square of 0.5, square of 1, square of 2. Second step, then you go to mean. You take the mean of all. How many molecules are there? 3. So this is the mean. And at the last, we put a root. So this is it. How will we calculate this? So this is 0.514. That will become 5.25. 5.25 by 3. Okay. So when you'll solve, this will be root 1.75. So root 1.75 is 1.3229. So this is coming kilometer per second. Now coming to the average speed. When we are calculating the average speed, for the average, it is simply 0.5 plus 1 plus 2 divided by 3. That is 3.5 by 3, which is 1.1, then 1.666, right? This much kilometer per second. So when you are calculating the ratio, VRMS by V average. So this will be 1.3229 divided by 1.1666. So answer will be around 1.13. This will be the ratio of it. Noted? One or two questions we'll see more.
Ma'am, can you scroll up?
Written the question all?
Yes, ma'am.
Yes, ma'am.
Yeah, Shaima, you can. That I have this 1.1166 was easy to calculate. So this I did, but this one I have seen from the calculator. So that's why this has these many decimal values. You can round it off. You can round off all these because this will be 1.16666 bar, right? So we have to take it as 1.167. Class done. Are you done with this question? Question one.
Yes,
Yes,
ma'am.
ma'am.
Okay. So see this question, this is also a very easy question. It's just that we have so many formulas for formula for RMS. That's why RMS is one of the most important. Every velocity is important and any can come, but RMS is the frequently asked because different formula there. So you have to calculate RMS. Now see, the formula that we were using previously, right now the issue is that there isn't any information about the individual velocity that we can put the square and then the mean and then the root. No. So one thing it has mentioned at STP, and I have told you standard temperature and pressure. Pressure, we take the atmospheric pressure. So there was one formula yesterday I told you for VRMS, that was 3 PV by capital M, because molecular mass of ammonia is given, right? 17. So this can be taken, atmospheric pressure is 1 atm, that is 10 to the power 5 pascals. This is multiplied to 1.01 also, but that I'm leaving right now. And yeah, volume 22.4. At STP, the volume is 22.4. So for meter cube, we'll multiply it with 10 to the power minus 3. Remember, 22.4 into 10 to the power minus 3 is the standard wall. At STP, these two values are for STP. Molecular weight is 70. This you can calculate. I'll tell you the answer for this. Answer is 632.8 meter per second. Okay. Write it. One more question on RMS only I want to do. First you write it, text me done, then that question I'll write. All have completed?
Yes, ma'am.
This gram molecular weight you should already know from your chemistry, though it is mentioned in this question. See, it's also a very small question if you do it systematically. Remember, in the previous part, what did we see as the formula? 3 PV, whatever, is by M. Now look, pressure, volume, and everything will be constant, because nothing is mentioned as such that is showing you that these are put in different containers. Oxygen and sulfur are making sulfur dioxide. So definitely this is one compound that we are talking, not individual elements, not the atoms. We are talking about the complete molecule. So pressure and volume for all the molecules will be the same. So rather than solving the pressures value, volumes value, and then cancelling it, you can directly see that RMS velocity is inversely proportional to the gram molecular mass, right? So what do we have to calculate? O2's, what will be the gram molecular mass of O2, because it has said no O2. So for one oxygen it is 16, so it will be 32, and this you all know also, this much 32 is for oxygen. Sulfur, now coming to sulfur dioxide, SO2. So 32 plus 32, 64. So when we are talking about the velocity of O2 by velocity of SO2, they'll be inversely proportional. SO2s will go here, root 64. O2s will come here by root 32. This will be 64 by 32. This becomes 2. So we can see from here that VO2 by VSO2 is equal to root 2. We had to prove RMS velocity of O2 is root 2 times the RMS velocity of SO2. So this is proved. Okay. Note down this question. Is it clear? Are all these three questions clear to everyone? I hope you are able to understand.
Yes, ma'am.
Yes, ma'am.
Again, class, after completion, just text me. One last question is left. After that, we'll start with oscillations. Class, just tell me while I'm writing, is the cursor visible or does it appear once I've finished writing? Tell me when I'm writing from this. Okay. Is it visible while I'm writing or does it appear after I've finished?
Ma'am, it's visible
Ma'am,
while
it's
you're writing.
visible.
Okay, okay. Please write down the question first, then I'll discuss it. It's a very easy question. It's just lengthy. This question I've given you so that this revise with the laws which we've studied. This is from all the laws. So you'll be able to get your answer within seconds. It's a very easy question. First write it, tell me done, then I'll discuss the solution. And those who have completed writing, they can try and tell me the answer for the volume and the pressure in the chat box. Have you all written the question?
Yes, ma'am.
See, this says that a gas at 27 degrees Celsius in a cylinder has a volume of 4 liter. Pressure is 100 Newton per meter square. So volume is 4 liters and pressure is 100. This is what we have. V and P means P1 and V1. It is saying now pressure is this. What is the new volume? Temperature is constant. Can anyone tell which law is this? Temperature constant. Pressure and volume are given. Yesterday we have done all the laws. Yes, class, which law is this? Where the temperature remains constant and it gives a relationship between the pressure and volume. Then first law,
Boyle's law.
Boyle's law, yes. Don't remember it like first and second law because these are not thermodynamical law that we can remember as first law of thermodynamics. If I just change the sequence, that cannot make it as the first law or second law. Okay, if I write Charles' law as the first one while teaching, so that doesn't make it the first. Never write this in the exam. For thermodynamics, you can take it as zeroth law because these are standardized laws. Like the name is first law. Right now, you have to use proper name. So Abir is right. The law is Boyle's law, which tells that pressure is inversely proportional to the volume. So P1 V1 is equal to P2 V2 as your PV will be constant. So here we have V2 will be P1 V1 by P2, right? So P1 is given as 150, no 100. So this is given as 100. Initial volume is given as 4 liters. This is by 150. So 40 by 15. Or we can reduce it further also. This is 2. This is 3. So we will get 8 by 3, 2.67 liters. Second part, this is the first part. Second part says, it is then heated at constant volume. And now the temperature is 127 degrees Celsius. Earlier temperature was 27 degrees Celsius. Now temperature is 127 degrees Celsius. Okay. First pressure is given as how much? 100. 100, no, 150. The initial pressure, right? Or 100. Yeah, initial pressure is 100. Okay, so initial pressure is 100. Okay, one more thing, it is just saying calculate the change in the volume. Here in this question, it is saying change in volume. So change, we'll calculate V2 minus V1. So if this is 2.6 liters, check what is the precise value of 8 by 3. So this will, okay, the previous one was greater. So this will be written as 4 minus, change in volume will be V1 minus V2 because your volume is, this has compressed, it has not expanded. So 4 minus 2.67, it will be 331, right? 1.33. This much liters will be the change in volume. Now, in second part, we have the new temperature. See, earlier temperature was 27 degrees Celsius. Now we need to convert it. Okay, because there is not change taken. So 27 plus 273 will become 300 Kelvin. And the new temperature is 127. That will become 400. So T2 will be 127 degrees Celsius. That is 127 plus 273. That is 400 Kelvin. Initial pressure is already given as, okay, we'll not take the initial pressure class. It is saying how much it has increased to 150. See, it is saying it is then heated, means from this pressure it is heated. So again the pressure will change. So we will take 150 Newton per meter square. We will not take 100. If this wasn't mentioned that it is heated after this, right? It is saying it is then heated at the constant volume. So 150 will be taken as our initial pressure. P1 will be 150. So which law introduces us about the constant volume class? Constant volume relationship between pressure and temperature. Which law? At constant volume, there's some relationship between pressure and temperature. What it
Charles.
is? Yeah, it will be Rayleigh's law. So it says that pressure is directly proportional to the temperature, right? It is directly proportional to temperature. So P1 by T1 will be equal to P2 by T2. This is the rule. So we just have to find out the value of P2. So it will be P1 T2 by T1. P1 is 150, T2 is 400 by 300. So this will be 200. Okay, so this answer for this is 200 Newton per meter square. And answer of this is 2.67 liters. Okay, so this is how you have to use all the laws. Please write it, then I'll start with oscillations. Yes, Shaima, it's better that you mention the law. And even if you're not mentioning it, you have to remember the name of the law, because sometimes directly questions are asked, tell the name of the law. So it's better you remember the law, and once you have remembered it, you can easily put it into such questions. Usually there is not no such mark in these kinds of questions where you have to mention the law, because it's just a numerical without any theoretical part. But just in case if there are questions where you have to mention the name of the laws also, so in those cases you have to put up which law you are using and why are you using, because it is saying that the relationship is constant. And when you are saying the relationship between pressure and temperature is directly proportional to each other, so then you will say that their ratios will remain constant, right? If we say P is directly proportional to T, so what can we say further? P1 by T1 is equal to P2 by T2. So how can you say that pressure is directly proportional to temperature? Because of the law. So that's why it's better if you mention the law also. Class done?
No, ma'am.
Class, in this chapter, you will get a lot of usage of trigonometric functions. Okay, so these are the basic formula of the trigonometric values. The trigonometry, you already know all these things, right? So these are some things that are common, but many students don't remember it. Like sine 90 plus theta is minus sine theta. Cos 90 plus theta is minus cos theta. But when you write sine 90 minus theta, it is just sine theta. So we use this, and these things will be utilized in this chapter. So 90 plus theta, then you have 180 minus theta, cos 180 minus theta, sine 180 plus theta. So these things, 90 plus theta minus theta for sine cos, 180 minus plus sine theta for sine cos, not waves, oscillations. Okay, SHM, the second last chapter. And this again is 360 plus, this is sometimes used. And then the values, sine 30 degree, 45 degree, 60 degree, 90 degree, 120 degree, sine 180, sine 270, and then cos 30, 45, 60, cos 90, 120, 180, 270, 360. And this conversion of how to convert degrees into radian, because radian is the SI unit for angle. Right, SI unit of angle is not degrees, it is radian. So you need to know how to convert degrees into radian. So 1 degree will be pi by 180 radian. So quickly just make a note point and write down about the trigonometric functions. Quickly, all of you remember this. It's just a revision. Some of you must not be knowing some of these. So remember those which you do not remember. And write it, this you already know many things. So there's nothing to discuss also here. Just write it. If you have any query in this, ask. Then I'll start with the periodic and SHM, how to identify periodic and SHM. Before conditions of SHM, we'll see the types of periodic motion. This is the topic. SHM, in oscillations, you have SHM, that is simple harmonic motion. We'll see that. Write it and just update me in the chat column. Quickly copy this.
Can you please scroll down? 1 times the limit.
Yes, Shaima. For sine 90 plus theta and sine 90 minus theta, both are equal to sine theta. But cos 90 minus theta is sine theta. But cos 90 plus theta is minus sine theta. That's why I have written all these things, because there's no pattern for this. This is cos theta plus for both of them. No, pi means 180. So pi by 2 is for 90. 2 pi means 360 degree. Remember, pi is 180 degree.
Ma'am, can you scroll up for a second? Done.
Done?
Homework.
Please text me done once completed. Okay, class. Now coming to the simple harmonic motion, that is your chapter oscillations. Okay, so chapter 14 is your oscillations. So SHM stands for simple harmonic motion. Before that, just understand what is simple harmonic motion, what is an oscillatory motion, what is a periodic motion. So periodic means from the term period. It means that it is repeating itself after a fixed interval of time. Okay, so if the motion is repeating itself after a regular interval of time, if it is repeating, okay, after a regular interval of time, it is called as the periodic motion. So the regular time interval is the time period of the periodic motion. Means, let's say, yeah, look at the examples. Revolution of Earth around the sun, it's a periodic motion. You know, the Earth will, if this is the sun and you have the Earth. So, you know, if the Earth has started moving from here, this will come back here after 1 year. It will come back. Then again, it will go and come back from to its mean position back like this. It will again. That's a periodic motion. Or, you know, Earth is there and around it, moon is present, right? So we know that moon will again come back to this position after 1 day. So these terms, 1 year, 1 day, these are what? These are the time period. And we have been using the term time period so often. Now, that is what is periodic motion. It has to repeat itself after a period of time. Then this is what is meant by oscillatory motion. Okay, this was a periodic motion. What is an oscillatory motion? In oscillatory motion, there is to and fro motion. Like if there is this is a rough surface, attached to it is a pendulum. It goes here, comes back to here, again goes here, comes back here, like this. So there's a to and fro motion about a definite point. So what is oscillatory motion? If a body in periodic motion, means here in periodic motion, moves along the same path to and fro about a definite point, then the motion of the body is a vibratory motion or the oscillatory motion. Like the motion of the bob of swinging. This is the bob, this is the thread, this is an oscillatory motion. It is oscillating, coming back and forth. When a loaded spring is pulled and released, if the spring loaded means it is loaded with mass, this is pulled and then you have released it. So it will go like this and then like it will expand, contract, then expand, contract till the time it is whatever momentum it has gained, till the time all the momentum is lost, energy is converted, it will be oscillating, it will be moving like this, bouncing back, coming forth, back, coming forth. So that is what is an oscillatory motion. It's a type of periodic motion only, because it repeats itself after a fixed period of time. But here the difference between periodic and oscillatory is that in periodic, time period is fixed and that won't change. But in oscillatory, once the momentum is lost, or the momentum slows down or the speed slows down and the energy is converted, so this can reduce, the time period can reduce. So this is the difference between a periodic motion and an oscillatory motion. Oscillatory is a type only, but there is to and fro motion about a definite point. So you can take the examples. In periodic, you take the example of the moon, which is revolving around the earth, right? Which is rotating. So if when earth is rotating, moon is revolving around the earth, and after one day, you know the moon will come back to its initial position. And again after one day, it will come. Again after one day, it will. So this one day, this becomes the time period. In oscillatory motion, we talked about, best example is take the example of the swinging pendulum. It keeps on moving, 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 and then it can occur that it has just stopped. What is simple harmonic motion? See, in simple harmonic motion, there are various conditions that have to be followed. And if those conditions are fulfilled, then we say that SHM has occurred. Now, what are those conditions? See, a particle is said to execute SHM if it moves to and fro about the mean position, that is the equilibrium position. To and fro motion is there in a straight line. And the graph between displacement of the particle. So you see, uh, if it moves to and fro about the mean position in a straight line, and the graph between the displacement and time is a sine or a cosine curve. It's very important. See, it's a type of oscillatory motion. SHM is a type of oscillatory motion because there is to and fro motion. But every oscillatory motion will not be considered as SHM because there are few conditions that we'll see. See, one example of it is the pendulum one. Pendulum is there in your syllabus also. Now, this is the resting position. So we say this is the mean position. Mean position means the starting. And this is one extreme end, this is other extreme end. So the pendulum will go like this. Bob will reach this point, right? It will come back like this. Then the bob will go here. It will reach this and then come back here. One extreme on right, other extreme on left, and then back to the mean position. This is what is called an oscillatory motion. So you have this motion of the spring is there. Okay, what is this? Oscillation of the a simple pendulum is there. This is a simple pendulum. There are various examples of this, like that spring system which we saw, that is an SHM. Oscillation of a spring. See, there is a spring. At the end, we have attached a block. This is the resting position. If it expands, if it reaches here, and then it can be compressed, let's say till here, then it will come back. So like this, it is an oscillatory motion. Sine curve, I'll tell you. Or there is one more example. YouTube problems we have seen in the fluids chapter. So suppose this liquid is filled and here we have pushed it. This is the mean position. So it will rise from here. Then again, it will be depressed. It will rise from here. Then again, it will be depressed. It will rise like this. It will be oscillating. So liquid in a U-tube. Now this liquid in a U-tube has been deleted from your syllabus. Earlier, this was also there in your syllabus. Now, what are the conditions of SHM? Right. What we were talking about the sine curve also. So firstly, it has to be an oscillatory motion. It has to be a complete oscillatory motion. To and fro motion should occur. Like see, in periodic, to and fro motion is not there. A time period is there. To and fro motion is not there. What's a sine curve? This is how a sine curve, and when you'll come to your class 12th, you will have these sine curves and cos curves a lot in your current. So this is how you will get a sine curve. This is a sine curve. For a cos curve, it starts from 90 degrees. This is a cos curve. That is a cosine curve. Okay, someone was asking this. Yeah, Shaima. Restoring force should act towards the mean position. Why? Class, look at these examples. Look at the spring example. Suppose I have taken an external force, I have used my force. So my muscular force is the external force for the system. And I have pulled the mass towards myself. So external force has pulled it. Like I have used my muscular force to pull it. So that my muscular force, the force that I am applying, will be external to the system. System surroundings we have studied many times in this session. Now, if I have pulled it and I have stopped it, why is it going backwards? Like isn't it coming, why is it coming towards the mean position? Because there's always a restoring force that develops. In oscillation, in SHM, remember, simple harmonic motion, there is always a restoring force that is developed. And this restoring force is directly proportional to the displacement from mean position. So there's a constant that we write. Constant is K. This is the constant that comes. And why are we putting a minus sign? Because we know that the restoring force will always be directed towards the mean position. See, if it is not restoring force, if it is not directed towards the mean position, the body won't come back to its initial position. So how will it oscillate next? So because this is because restoring force acts towards the mean position. Okay, it will be directed towards the mean position. So rest of the things, characteristics of SHM, I'll discuss later. Remember, this is a very important formula. F is equal to kx. Most of the times kx is directly used. Please write all these points.
Ma'am, can you scroll up?
Ma'am, can you scroll up?
Done, class? Okay, okay, right. Zainab, done? Okay, coming to the characteristics of SHM. So equation of displacement is very important. So displacement, we have studied that what is the displacement, like the example I was giving you of the spring. If there is a spring which is present, there's a block that I have attached. This is what, this is its starting position. That is the mean position, right? Now I have expanded it. The spring has been expanded. So this is the same block. This was, let's say, the initial position. So this much of displacement has occurred. One more thing, class, I forgot to tell. The way F is equal to minus kx is there for linear motions, for linear translations, like translational motions, we have F is equal to minus kx. If it is rotational, torque will be instead of force, you will write torque. Torque will be minus k theta, because theta is the angular displacement. Torque is the angular force. So this is also valid. Okay, same thing for that. Now coming to the equation of SHM. What was the equation of SHM? F is equal to minus k of x. Okay. Now, let's say m is the mass of the body. So what will the acceleration be? Force divided by mass. Force is minus kx. So divided by m, this will be the acceleration. So one equation, this is one equation of acceleration. And one more equation of acceleration that you know is, see, acceleration is double the velocity, double differentiation of position. Like this is dv over dt. So it will be written as d square x over dt square. So this will be 2. Now both of these are accelerations only. This is also acceleration. This is also a formula of acceleration. So I can equate both of these. Minus kx by m is equal to d square x by dt square. Let me bring this on this side so that this becomes positive. D square x over dt square plus kx by m is equal to 0. Now class, one thing, angular frequency, just a small note point that will help you remember. Remember this, that omega square is equal to k by m. So you can say omega is equal to root k by m. What is omega? It's the angular velocity or frequency. Right? So in this, if you see, k by m can be extracted separately. So we will get d square x over dt square plus omega square x is equal to 0. This equation is called the second order differential equation of SHM. Second order differential equation of SHM, which is very important, this equation. Okay, so when you take out the solutions of this equation, solution of equation of SHM, you will get these. X equal to a sine omega t plus phi naught. X is equal to a cos omega t plus phi naught. Now, you have not done these things before, no? And we didn't have any equation for wave till now. Yeah, this part, please do it very carefully, because in class 12th, you will be having chapters of alternating current. There, these equations will come again, AC generators and all. So prepare this here, because in class 12th, it will be easy for you to know. This part I'll tell you later. First, you copy down the second till here, copy. Okay, this part I'll explain you, because then we have to see the wave also, wave part. Please write from the characteristics of SHM. Is it clear how we got the second order differential equation? That is clear to you?
Yes, ma'am.
Okay, class. Please copy this. No, mean position is this. Equation of displacement is this. When this extension has been produced. Mean position has no equation. It is the starting point. There isn't any displacement that has occurred. So we are studying for this extension. That's why we are taking this X. Okay, all of you have completed? Equilibrium position, Shaima, equilibrium position, yeah, that is same. Okay, okay, yes, yes. Equilibrium position and mean position, they are same. Because in equilibrium, the body is not moving. That is right, Shaima. Yes, Zainab, the class is ending only. Just 1 or 2 points. I'm just ending this class because this will take a little time to explain. See, class, just a few things that will be covered in the chapter waves. When there is one wave, this maximum displacement from the mean position, this maximum displacement, this is what is called the amplitude. So when we write this equation, this is what the amplitude is represented by. Here, before the trigonometric function, a, b, c, d, whatever symbol you're using, this is where the amplitude is there. So this a is actually the amplitude. Now suppose I draw two waves. This is one wave and second wave is this. So can you see there is a difference in the angle also between the two waves? That is what is the phase difference between the waves. So this phase difference is called the phase constant. Phi naught is representing basically this difference, angular differences between the waves. So there are two equations that can be used. You can use sine also, you can use cos also. Both are correct. In case of SHM, sine and cos. But be very careful that this is nothing other than sine and cos. So these are the two values of equations that we can use. So if I say y is equal to a sine omega t plus phi naught. So for mean position, remember x will be equal to 0. Okay. And if I say y is equal to omega t plus phi naught, in extreme position, this displacement will be equal to the amplitude A. Amplitude is the maximum position. So if I say body is at the mean position, this is its amplitude, right? So at the extreme end, the whole displacement will be equal to its amplitude, because amplitude is the maximum position from displacement. And in mean position, it has just not started moving, right? So x will be 0. That's all what you need to remember. Rest of the things I'll discuss tomorrow. Quickly copy down this, and one by one you all can start leaving also. Next week can only now be complete this. All right. Okay, class. Thank you. Bye. This you can copy, please.